Hello guys. A few days ago I was stuck on a problem. How can I instance animated geometry with proper born time? After doing lots of R&D, I was finally able to find the solution and I'm very happy to share it with you. So today, we will learn a fantastic trick how to instance animated object and how to instance animated object on an animated source with proper alignment. As you can see here, a nice rain splash FX, but this is not a bunch of crown splash simulations. I had made 4 variations of crown splash and instance it with a time offset. Before diving into Houdini, please make sure to like, share and subscribe to my channel. If you find this tutorial helpful, you can support me on Patreon. So here, I had 4 variations of crown splash which I have already cached to disk. You can make your own crown splash sim and cache it by making some variations. In this tutorial, I'm not going to show you how I have made this crown splash. Take a grid node. Add a camera and adjust the view as you like, because we are going to cull the grid which is not visible in the camera. This will save our memory and make the instancing a bit faster. Increase the rows and columns to 30. Take a camera frustum QL node. You can get this OTL from the Clip package. I will give the link in the description. This package contains lots of useful nodes which will save your time. Reduce the near clipping to 4. From the center and overscan parameter, increase the overscan to 1.7 on both sides. Now take a group create node and connect the camera frustum node to the second input of the group node. Now take a blast node and delete the group that we create. Make sure to toggle on delete the non-selected. Now take a pop network. Select the pop source node. In the just born group string write born. This will add every particle which is just born into the born group. Reduce the constant birth rate to 1000. This is per my PC specification. If you have a higher configuration, you can crank this value higher. First, let's see how many frames my crown splash is available. So it's for 8 frames, but we are going to use double the value of the total range. That is 16. So in life expectancy, under pop source, put 16/$FPS. This is going to delete the points every 16th frame. In the jitter birth time, select none. Take a pop wrangle node. Toggle on group and select born group. In the expression, write this small vex code. This is going to store the frame number when it was born. Now take an attribute delete node and delete some unwanted attributes. Now take a wrangle node and write this expression. Let's add 20 frames pre-roll to our simulation. The reason behind I'm putting modular 4 is because I have 4 variations. In case you have 3 variations, then put 3. Now I'm going to make 4 groups based on index numbers. Now again take a wrangle node. In the group select the var01 group. In the code write this expression. First, we are going to clamp the frames value between 0 and 16. Then we will add the clamp frame value to a new integer variable named cache frame. Let's visualize the cache frame attribute by making a temp attribute. Now the final step is to make an instance path attribute. Copy the cache path directory and paste it into Wrangle using a double inverted comma. So here comes a bit confusing step. So my cache name is cluster_0 with the $F frame number, then the extension. So we need to remove the frame number and extension from the path that we pasted and again put a double inverted comma. Then add a plus sign. Then we are going to use the itoa function. Since we make our cache frame variable as an integer, this itoa function uses an integer value. Then again put plus sign, after then put a double inverted comma and write down the extension of the cache, in my case, it's in .go.sc. Then close it by adding a double inverted comma again. If you have an alembic cache, then simply put ABC. In case you have any issues while understanding, I'm going to show you the default file cache node. Let's assume this is your file cache node. As you know that $hip name means the Houdini file name and $os means the operator node name. Copy the path from the file cache and paste it into the Wrangle node. So here my operator name was file cache 1. After that, there is a dot. From there we need to remove the frame number and cache extension. Then add the itoa function after that add your file extension name. So here we had made it for first variations. Let's add an instance node and see whether it's working or not. So, it's giving me an error, because I forgot to add a point before go.sc. Now you can see the splashes are getting born on point which has index value of 0. Currently, it's too big. Let's add some random p-scale variations using attribute randomize. As you can see, the instance method is working too fast. So we need to copy the same Wrangle 3 times for other 3 groups. We just need to update the file path in other Wrangles. Let's do it and see how it looks in final version. As you can see, we are getting a viewport issue. Don't worry much about it, because in rendering it will look fine. Now the piece scale size is too much, let's reduce it by 25%. Now the final step is we need to add some random orientation on y-axis so the instances won't look similar. To do this, take a wrangle node and write this small expression. Now let's see how we can instance the same thing on an animated source. Take a sphere node, and convert it to the polygon. Increase the frequency. Now add a mountain node and let's animate the offset. Now from Pop Network copy paste everything. Now if you can see, the particles are staying at the same position where they were born, but the source mesh is getting deformed. You can either freeze the frame and then add the same pop network. After that you can do point deform with the animated mesh. This also gonna work, but I'm going to show you a new technique in which we are not going to use any kind of simulation. Delete the pop network. Take a timeshift node and freeze it to first frame. Add a scatter node. Set the force total count to 250. Now we need to set the ID attribute. Take a wrangle node and write this small vex. Now take a point to deform and connect the wrangle output to the first input, timeshift to second input, and animated mesh to the third input of point deform. We can add delta mush for a smoother surface. Now we need to set the random birth frame attribute using the attribute randomize. Take an attribute randomize node. In the attribute, name write birth frame. In the min value put your first frame of the timeline. In the max value put your end frame of the timeline. In the dimension set it to 1. In the spreadsheet you can see we are getting the birth frame attribute is in point like 1025.35. We don't want it like this. So to fix this, take a wrangle node and write this expression. Now take an attribute fade node. In the fade attribute type emit, and in the fade start frame type birth frame. As you can see now our points are getting faded randomly. Go to the timing tab. Reduce the value to 1 in fade frames, and increase the value to 6 in fade out frame. Bypass the attribute delete node, and everything remains the same. Let's display the instance node and see whether it is working or not. Cool, it's working, but there is some alignment issue. Let's try to fix it from normals. Take an attribute transfer node. Add a normal node. From the normals menu, select points. By adding normals, it's still not fixed. It is because when we are instancing anything on an animated source, we need to make sure the instance geometry is placed perfectly on the grid and its up direction is facing toward the Z+ axis. Currently, my cache up direction is facing in Y+ axis, but we need to make it face toward the Z+ axis. Take a transform node and rotate it in X axis by 90 degrees. Cache it again to disk. Do this for all other variations. Let's update our instance path with the new caches. As you can see, we are still not getting perfectly aligned instances. This is because we have calculated the orient attribute previously, which is messing up the things. Let's bypass the node and see whether it's working or not. Cool, as you can see we are getting our instance perfectly aligned with the deformed mesh. Let's make our sphere black color, so we can visualize more clearly. Let's create a flipbook and see. Awesome, it's working perfectly. By this method, you can instance an animated geometry on an animated source. A bonus trick for you, I will teach you how we can use copy to point to stamp on non-animated geometry. Take a copy to the point node. Take 3 geomodels. In my case, I'm going to use Pinhead, Crag, and Shaderball. Merge all of them. Take a primitive wrangle and let's add the name attribute. Take a grid node. Scatter some points. Take an attribute randomize node. In the attribute name write name. As you know, a name is a string attribute. But in the attribute randomize node we can't see any menu where we can set it as a string. To make it a string attribute in the distribution menu select custom discrete. Now in the type select string. In the value 0, 1, 2 write the name that you have written in a primitive wrangle. In my case, it's a piece 1, piece 2, or piece 3. Now display the copy to points. As you can see currently it's not working. To make it work toggle on piece attribute and write name instead of variant. Let's make some random scale values. This method is much faster than a normal copy to stamp. You can control the amount per piece by changing the weight amount. If you find this tutorial helpful, make sure to like, share, and subscribe. You can also support me on Patreon so that I will bring more awesome tutorials to you.